Good morning. I'm Allison Hahn, Program Manager for Advanced Methods of Manufacturing. I'm going to be discussing two separate work scopes today. One is R&D only support. That's the NEET-1 work scope. And then there's R&D and access. That is the NSUF 1.2 work scope. I'm going to be discussing both of those today. To clarify, NEET-1, the R&D only, is open to universities and national labs. NSUF 1.2 is open to everyone, industry, universities, and national labs. I just want to make that clarification because there are a few changes this year, so I want to make sure everyone's on the same page. The AMM Vision and Goals. The AMM program has not changed dramatically since it was first created in 2012 under the Cross-Cutting Technology and Development Program. The vision of the program is to improve the methods by which nuclear equipment, components, and plants are manufactured, fabricated, and assembled, utilizing advanced manufacturing practices found within other industries. The goals: reduce the cost and schedule to build these new plants, making it less expensive, faster, while also being more reliable. So for the NEET-1 focus areas, this is the R&D only portion of the work scope open to universities and national labs. We've called out four focus areas: factory and field fabrication techniques, advances in manufacturing processes, additive manufacturing techniques. We're looking for additive for advanced materials and multi-materials. We've funded a number of projects on stainless steels and Inconels and current materials. So we're looking to extend that process. And then development of in situ quality control techniques for high-speed manufacturing. Factory and field fabrication techniques, we're looking welding technologies, weld monitoring technologies. We have currently an online weld monitoring control system using optical methods. We funded another monitoring program that has recently ended. So I encourage you to go on to the CTD website, energy.gov/NE. You can find the Cross-Cutting Technology Development link. We have an annual award summary on all of our projects. I highly recommend you go and look at those to see what's currently been funded, because we do have a couple of projects in this area, and we are not funding anything duplicative. So I encourage you to look at that. Surface modification techniques and shop floor site operations, improving those processes. Manufacturing processes for components. I want to emphasize that here. The AMM program looks at components. We do not manufacture fuel assemblies. Fuel support assemblies, but not fuel. I want to emphasize that here very highly. Again, surface modification, cladding for those, corrosion and wear-resistant applications, all of that is included in this one specific focus area. Additive manufacturing, I'd mentioned that we have previously funded a few AMM projects: laser powder bed, laser dep, e-beam welding. We also have one project on monitoring laser powder bed processes. I encourage you to look at the work that's been done, build upon that. Include advanced materials, and multi-material is something that we're highly interested in this year. Again, stainless steel, Inconel, ODS. We have looked at those. Build upon that work. See the successes that they've been able to acquire and continue to move it forward. I apologize for the typo in this slide. It's NSUF 1.2, not C 1.2. This is R&D and access to the nuclear science user facilities. This is open to all universities, national lab, and industry. We're looking to further the manufacturing processes, something that would need NSUF access, including neutron irradiation, ion irradiation, post-radiation examination. These projects are bigger than the other projects in the terms of access funding. It is $500,000 in R&D support and access to that. If you're looking for a neutron irradiation, up to 7 years, $4 million is what we're looking at typically for those large long-term irradiations. We also do post-irradiation examination. We have ion beam facilities. We do ask that these results be tied to using the high-performance computing and tying that information into the modeling and simulation programs that we have as well. The components for NSUF testing need to be developed. This is not the development portion of your work. That should be done previously. We ask that all materials and components be available to the NSUF program within 6 months after award, so it's a quick turnaround. You're not doing R&D on the process at this point. This is further testing from that. I just wanted to clarify that as well. So the summary, again, the AMM program increased the reliability while decreasing the cost. Pretty straightforward. Another thing that the AMM program likes to point out is that the projects that the AMM program supports, we are looking for that acceptance by the codes and standards and regulatory bodies. That's something that we are highly interested in getting that acceptance and getting that out into industry. So I want to stress that. And then, of course, being able to be deployed in the commercial nuclear reactors, the extent of our R&D. And with that, I will open up to any questions.
Okay, please submit your questions through the question application on the GoToWebinar.
Sorry.
Allison, are there specific components for which additive manufacturing methods are of interest?
There are no specific components that we're looking for, just not fuel. We've done fuel spacer grids, safe ends, nozzles. We've looked at a few different types of components, just not fuel.
If a material is under investigation currently with a certain advanced manufacturing technique, can the same material be the focus of a different AM technique?
Say that again?
If a currently funded project is investigating a material with a certain advanced manufacturing technique, can you do a different advanced manufacturing technique on the same material for your proposal?
Yes. We've done laser powder bed and laser dep on 316, so that's not unprecedented, not at the least, no.
Would you fund a project that advances construction processes, i.e. construction progress and quality control?
I would have to see the proposal and see that how it's set up. That's a tough call. We look at fabrication and manufacturing, but we have considered construction processes in the past.
What are the expensive components to fabricate currently?
Large components, single-use components that aren't readily fabricated. I have a specific example off the top of my head. I can certainly get back to you though if you're interested in that. Just email me.
Okay, the draft FOA says NSUF 1.2 is lab and university led only. Can industry lead?
Yes, we are making that correction. Industry can lead NSUF 1.2.
Is concrete shielding considered under advanced manufacturing?
We have funded a number of concrete projects. So the concrete material, yes, that is included in AMM.
Will you fund NDE for building components of nuclear power plants?
Will we fund NDE of building components?
For building components.
I would need to see the proposal again. We've funded NDE in the past. It's been encouraged. So off the top of my head, I would say yes, but I need to see the proposal.
Is there an interest in identifying all the variables / parameters in the AM process and optimizing them
Yes.
to arrive at the required physical and mechanical properties?
Yes, we know this is a issue with AM. I'm highly interested in that.
What types of non-destructive measurements on additive manufactured components are of interest?
I would have to get back to you on that question. I know that they've looked at UT Other methods, I'd have to get back to you on that actually though, on specific.
Do you consider advanced joining or welding techniques as innovative manufacturing techniques under the NSUF 1.2 work scope?
Yes.
Allison, could you please repeat the website for the cross-cutting technologies summaries that you were talking about?
The website, the URL is lengthy. If you go to energy.gov/NE, there's a little link at the top that says initiatives for NE. There's Nuclear Energy Enabling Technologies. Click that link and you'll see the most recent publications. AMM's annual award summary is listed on that page. If you'd like to email me, I can send you the direct URL. It's just pretty lengthy to say right now.
Are studies that characterize the material and mechanical properties of components made with additive manufacturing of interest?
Repeat that again?
Are studies that characterize the material and mechanical properties of components made with additive manufacturing techniques?
This is where we need to be a little clear. This is a manufacturing program. There are materials programs that research specific materials. We are looking at manufacturing processes to increase the schedule, decrease cost, increase reliability. There are mechanical testings that need to be done with new additive advanced manufacturing techniques in general, but material properties that might go into more of the materials R&D work scope areas. That's something that we do need to be a little careful about.
These last two questions I can answer. The question here is, how do I get a copy of the slides? All of these slides will be made available on neup.gov after the webinar has finished tomorrow. And the other is a question about whether or not you can contact a program manager or technical lead to talk about your concept, your idea. The answer is yes. Up until the full application stage, you can talk with a program manager or technical lead about your project. Allison, is additive manufacturing of steam turbine within the scope of NEET-1?
Yes. It's within the nuclear plant, yes.